So when you take a look at the directions, it said to not only solve algebraically but graphically. So what I want to show you is look at number 2 in terms of graphically. So I'll verify what I'm going to do on the calculator too. So we should all know now how to graph this particular quadratic equation. We know it's x squared plus 7x plus 12. When you factor it and you found -4 and -3, what you know is that this graph is actually going to be crossing the x-axis at -4, -3. And remember your study of quadratics, we know that because x squared is positive, it's going to be a parabola opening up. So you're going to have some U shape looking something like this. So when you set up your polynomial and you're looking at the comparison of the y values to 0. So we say x squared plus 7x plus 12 less than or equal to 0. We want to know where are the y values on this function less than 0. So what you're doing is you're actually looking at this graph and where it falls below the x-axis. And notice right here is where this function is actually falling below the x-axis, which notice is between -4 and -3, which we got when we solved it algebraically. So this is the graphical approach, a way you can solve inequalities. When you go back to example number 1 and you factored it, you came up with 0 and -8. Again, one x-intercepts 0, the other one's -8. Again, it's still a parabola opening up, crossing through the x-axis at -8 and 0. What we wanted to know is where our parabola was greater than 0. So notice, where is the graph of my parabola? You're comparing the y values to 0. Where is this graph above the x-axis? Notice it's happening right here and right here. And notice on your number line, we showed that you were looking at your values greater than 0 and less than -8. That region between -8 and 0, notice, is falling below the x-axis. So it is not going to be solutions for this particular inequality.